Hi everyone, this video is an exercise 11H question 1e. So we want to find the area of the finite region that is bounded by the curve f of x, which is x root 4 minus x squared, with the x-axis and the lines x is equal to 0 and x is equal to b. Right, so in this question, the first thing that ideally we want to do is just having a sketch of the graph. And sometimes it can be challenging, but mostly in terms of exam questions you'll be given the graph or just maybe some simple functions, but it's worth to be able to sketch some of these graphs. So in this case, um, when we want to sketch this graph, it roughly looks like this between 0 and 2, because remember that's what we want to find. So between the line 0 and 2. So first of all, in terms of the roots, so the roots are 0, and then we also have 2 as the positive and minus 2 as well. But again, we are only concerned about 0 and the region between 0 and 2. So and if we just look at the behavior of the curve, it's going to have a shape of this form roughly between 0 and 2. So again, the whole point of this exercise isn't really a sketching graphs. It's more just like basically being able to integrate, but just in case we are sketching the graphs. And in this case, we want to integrate between 0 and 2. So we can rewrite this as x times 4 minus x squared to the power of half dx. And now we can use the reverse chain rule. So we can add 1 to make the educated guess of 4 minus x squared, and then 1 plus the bracket, because outside of the bracket it looks like we have the denominator of the inside. So we'll have 3 over 2. Now let's differentiate this and see how good this guess is. So we'll get 3 over 2 times minus 2x 4 minus x squared to the power of half, and this cancels and we get minus 3x 4 minus x squared to the power of half. Right, so this is almost the same. We just have this additional coefficient, which is minus 3. And in this case, that means that we need to have minus 1 over 3, then 4 minus x squared to the power of 3 over 2, and then the limits. Yeah, so we just substitute these, and the answer is 8 over 3.